All right, this is the last learning item that we have before our test for the next unit, and I just need to show you two final things. Number one, to be able to count the number of valence electrons given an electron configuration. So to define, a valence electron is an electron that is in the outermost energy level. So when you have an electron configuration, what you'd need to do is identify the outermost energy level. So like for example, in that case, the outermost energy level is the second energy level. And in that second energy level, if I look, there are 2 electrons. So I would say that there are 2 valence electrons. Now I know that's not the question that's right here. I am just using this page in your homework as an example so that I can do a lot of these and help you understand how to count valence electrons. So I am not giving you the answers to this assignment. For B here, if I had to count valence electrons, I would find the outermost energy level, and the outermost energy level is right there. And so in the outermost energy level, there are 2 electrons here, and there are 6 electrons there. That is 8 electrons, 8 valence electrons in the outermost energy level. For D, the outermost energy level is here for D, and that would be 2 valence electrons. And E and F are both really good examples because when you're looking for the outermost energy level, it is not the third. The outermost energy level is the 4th energy level, so that would have 2 valence electrons. So remember, the outermost energy level is going to be the energy level with the biggest number, and the biggest number is right there, 4. For F, if I'm trying to count valence electrons, the 5th energy level is the energy level that is furthest away from the nucleus. So that 5th energy level has 2 electrons here and 5 electrons there. That is 7 valence electrons. I'm going to keep just doing some more examples for A, B, C, D, and E. And once I do those, I think we probably should be good. I'm, again, not answering the questions for this homework assignment. I am using these as an example to show you how to count valence electrons. So for A, looks like there are 8 valence electrons, 2 electrons here, 6 electrons there, that's 8. In B, the highest energy level is 5. So in that 5th energy level, there are 2 valence electrons. For C, the highest energy level is right here. And in that energy level, there are 2 electrons, so that would have 2 valence electrons. Highest energy level is 3, 2, 4 valence electrons. Highest energy level down here is 6, but there's also a 6 over here, so that is 5, 6, 7 valence electrons. And that should be good for counting valence electrons. That's enough practice. It's not hard. You just have to find the highest energy level and count all the electrons that are in that energy level. Last topic, if you need to write the electron configuration for an ion. So when I am doing this, I always start by drawing the electron configuration normal. So for calcium, the normal electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. That's calcium. Calcium has 20 electrons, and if you add up all the superscripts, you get 20. Or I could use a periodic table, look at where calcium ends, and when I find that, I would find that it is in the 4s2 block. So now I got to look at the charge. To become plus 2, that means you lose 2 electrons. If you are going to lose 2 electrons, these electrons right here are the ones that would be lost. So I am losing them right now. And then if I lose them, That's the electron configuration, which happens to be exactly the same as the noble gas argon. So the answer to the question is identify the noble gas. Well, that would be argon. Argon is the element that has the electron configuration of 3p6. So if I go on here, click on electrons, go over to argon, and if you look, 1s2, 2s2, 2p6, 3s2, 3p6, the electron configuration is right there, argon. Let me do one more of these for just going through the logic if it were a negative ion. So one more of these. Here's my my homework assignment. I don't know, shoot. Nitrogen seems like a good one. So if I were to do this for nitrogen, first thing I'm going to do is write the electron configuration for nitrogen. And nitrogen is 1s2, 2s2, 2p, 1, 2, 3, 3. So if I went to ptable.com, nitrogen is right there. You can look over on the left to see what the electron configuration is. Now, this nitrogen has a -3 by it. So to get to be -3, that means I have 3 more electrons than I normally would, because that's how you get to be negative. So 3 more electrons means it's not going to be 2p3. I'm going to add 3 electrons to that, which would be 2p6. And then if I look at a periodic table, I suppose I probably wanted to see that. That would help. So I crossed off the 3 and I added the 6. And when I add the 6, if I go to ptable.com, I was here and I added 3 electrons. 1, 2, 3. Neon, neon is the element that has the electron configuration 1s2, 2s2, 2p6. So neon is the element with that configuration. That should be enough to get you going on those. I think you can do electron configuration for ions. Don't forget that the next class when you come in is your test on this particular unit. So make sure that you are prepared for that test. You can do the review materials there. Any answers for the reviews, there's quite a few review items there. Any answers can be found in this red folder right here, right up at the beginning, where it's got some answers for the review items. Good luck studying, and I will see you soon.